went. My understanding is that the internet was quite frustrating. That was the case. Yeah. So I know that I had asked you to work on the web quest, and that my understanding is that you worked on that pretty well. Would you, my dear, please put those cards away right now, because it's not hard playtime. It's or science time. I wanted to check in with you about that to see how well it went, because I know that in the last class, like, some people got it done and some people got a little ways, and so I just wanted to kind of know where you're at. So if you need to pull it out so that you remember, that's totally fine. Otherwise, you can just look up here. I'm just curious how far you got. So would you raise your hand for me if you got through at least part one? Part one. I'm just looking. I'm not grading yet. Just curious if you got there. All right, raise your hand if you also got through part two. Okay, so that was kind of where we dropped off. Two. How about three? Devoted kid. Four? Kinda. That's okay. I'm just curious. All right. Okay, cool. So that helps me out. So I just want to let you know. So I apologize for the fact. I mean, it's obviously not my fault, but that the internet wasn't working. That kind of fell through yesterday. That said, I can't give us just another day to do it in class, because we have everything set from now until spring break. And I don't know about you, but I don't want to have to come back during spring break to finish up where we're at. You know what I'm saying? So what I'm going to ask is that the homework that I was going to give you for today, I'm going to push back. If you have not yet finished the web quest, so that's however much you need to do, okay, I would like for you to get that done before class tomorrow. Does that seem reasonable? Okay, so if that means that you need to do 6 sections or 5 sections or however many it was total, great. If it means that you just need to finish up the last one, great. Figure out a way between now and this time tomorrow to get that done, okay? I'm going to ask again that you please put your phones away. I don't want to see phones out at all during this class period from now until, June 1st or whenever I see you again. So, just please put them away. And again, WebQuest, I am going to collect it tomorrow at the start of class, okay? To make sure that we've got it done. Issues, questions, or concerns there? Okay. So we are going to do a capture question. I'm putting that in air quotes because you don't actually need to get your capture questions out. The thing you need to get out is that brown piece of paper that we started on Tuesday. We did the network bingo on one side, and then we started taking some notes on the other side. So if you would please get that piece of paper out, we're going to look at the graph that's at the bottom. Okay, the thing that we didn't quite get done when we were together last time. I already did attendance, so I will try to remember to get this, but if you remind me, that'd help with it. Thank you. So we started looking at this at the end. Does anybody need a copy of this? Do you need one? Will you take your earbuds out for me, sweetheart? I'd really appreciate it. Then I know I've got your attention. That helps me a lot. Does anybody else need a new copy of this? Oh, so many of you. 1, 2, 3. Okay, I think I've got perfect. Everybody else put your hands up. There you go, you're welcome. And just a friendly reminder, as we're starting off trimester 2, we are starting off with a clean slate, right? We are starting off, everybody's got an A, which is really great. All you have to do is keep it. All you have to do is keep it. And one of the best ways to do that is to hold on to your stuff and to make sure that you get your homework done. So that means that tonight or sometime between now and tomorrow, what are you going to work on? Homework. That homework. And what homework are we talking about? The web quest, right? So just a friendly reminder that that's what you need to do. All right, so we're looking at the bottom of this. We're looking at the graph. And as we talked on Tuesday, we were talking about global climate. We were talking about global warming and global cooling and how the CO2 levels can tell us something about what's happening with the climate. Okay, so this graph here is not a graph of temperature versus time, but it's actually CO2 or carbon levels versus time. How did they get carbon levels from way back in the day? Yeah. Remember those ice cores that we talked about where they dig really, really, really far down under Antarctica or under Greenland where it's been frozen for a long time? They can find out about the carbon dioxide in the atmosphere based on that, which is pretty cool. So we've got carbon carbon dioxide levels from as far back as 400,000 years ago. And you notice that they kind of go up and down and up and down. We're going to do this in a couple of pieces, and I'm going to ask that you work on this in pencil. So if you don't have a pencil out right now, pull one out. If you need one, talk to a table mate to see if they can let you borrow a pencil for a moment. Okay? I would like for you, based on your kind of what you see here, to draw what you think. I'm just going to draw a line here. So we're just going to look in this time frame from 200 to 100,000 years before today, or before 1950. Okay? I would like for you to draw what you think the graph looks like in these two, in this little section. Okay? So use your scientific knowledge, use your background, make a prediction, okay? Make a prediction as to what is going on right there between the two yellow lines that I've got. What do you think the graph is going to look like? And then once you've got a graph and it looks like your other teammates have a graph, then what I'd like you to do is to have a conversation. Compare your graphs. They might be kind of jagged, but kind of like the high points and the low points. How high did they go? Where did they happen? Talk about it. I like it. But it's an informed choice, right? An informed jaggedness. All right. Have you had a conversation? All right. Eric, I'm going to pick on you first. Is that okay? Sweet. Can you describe for me what you had graphed in this yellow space here? Okay. So how far down was kind of the farthest down that it went? Okay. So down in this area here, and at what time did that happen? 150. So between 200 and 150, so that'd be like 175. And it was like, here is kind of where you put your dot. So I'm just going to it's kind of like a funny little connect the dots. Was it a straight line or was it a jaggedy line? Okay. So we kind of expect something like this. Okay. How high did it go? To the 300 mark. And why did you choose the 300 mark? Okay. Fair enough. And where did that happen? Was that like straight up or did it happen over here? Right here? Okay. So it may be like 125-ish, something like that. Something like that. Okay. And then where did your story end? That was a lot of stuff. Say that again.
So like halfway down like that. No, not like that little box. Halfway down the box, the top box. Yeah, like right there.
Okay.
Back up to the top right corner.
Like there?
Yeah.
Okay. So like this?
Yep.
Okay. So that's what Eric and maybe the rest of his team suggested. No, just you? You're speaking just for yourself. Okay. All right. Let's see here. Constance, is that what your graph looked like?
Yeah, pretty similar.
Pretty similar?
Mine didn't go all the way up to 300, but it was almost there.
Okay, so like maybe down to like here-ish?
Yeah.
Okay, cool. Braden, what about you? What did your graph look like? Was it?
Mine was similar to theirs.
Uh-huh.
But like it didn't go down as much and it didn't go as high as theirs.
Okay, so maybe your, like it kind of went like to here-ish or something and like to there? And why did you make that choice?
Following patterns of the forest.
Awesome. And I like the fact that you said that because that was going to be my next question is, for all of you, you have kind of similar ideas and maybe a little bit of different. Did yours go down then, Braden, at the end? Or did it kind of like around there? Okay, cool. So in all of this, you have not gone and dug ice cores, right? It's not like you've been doing that, but you are scientifically minded and you can follow patterns, just like he said. So it goes down and up and down and up and down and up, and you're following the pattern. That's exactly what scientists do. We weren't alive back here. The only thing we can do is to follow patterns, right? So let's see how we did, because we have this data. This is what it actually looked like. This is what the actual levels were. So this is why we do it in pencil, okay? If you would like to now draw it in pen over top so that you can mark what it actually looked like, you can do that. If you would like to erase it, that's fine too. But I would like you to have this pattern. So this is the part we're talking about from 200 to 100. It's this piece here that we're talking about. So they had kind of a big spike, but it still does follow those patterns, doesn't it? Up and down and up and down. It didn't quite get up to the 300 level. It got down to about 180. So go ahead on your paper, and again, you can do this right over top the one that you did, or you can do it, you can erase it and fix it. I definitely know people in this room that prefer one or the other, and it does not matter. The important thing that I want you to notice is the pattern, right? Down, up, down, up, down, up. It's headed down. Okay. The other thing that this graph has on it that I wanted to just point out to you, although I heard a few different people saying this as I was asking questions, they have the 300 parts per million line marked as the highest historical CO2 levels, right? So, and that's kind of what your gut feeling was telling you. Don't go above 300 because it doesn't really make sense. This is the highest we had, and this one came just kind of close, okay? So you may want to mark that on your graph as well, where that's the highest historical CO2 levels that we have seen. And the lowest would be about 180. So it seems kind of like all of our data is in that range of 120 parts per million. Okay. So that's all well and good. You notice that. So it goes down and then it goes up. I'm going to copy this, although it looks pretty good, honestly, compared to what we had. I'm going to call that a win. We ended a little higher, I think. It's just a little over 220. So I think it really kind of comes down to here at the end. But pretty close. Okay, so you may notice, though, that on our graph we have not finished, right? Because I didn't want to make you do too many oscillations at a time. But now that we know what we know, I'd like you to make a prediction for those last 100,000 years. Okay? So we started off way over at 400,000 years. We go down, up, down, up, down, up, down. Make a prediction. Go ahead and draw what you think happens. You're scientists. Use that background knowledge. We know that climate changes, don't we? We know that climate changes because of natural factors, right? Changes in the atmosphere, volcanic eruptions, all kinds of things that can cause these changes. Make a prediction. Write something down on your paper. Commit. Because I'm going to ask you. Eric is probably off the hook because I just asked him before. Who else did I ask before? Constance is probably off the hook, but pretty much everybody else is. So I might pick on you next. Talk with your table mates if you haven't done so already. Do they agree with you? Does your graph look like theirs? What science background are you using? Not today. Tomorrow. Tomorrow? Okay. Is there a reason? Just a little bit. I'll just get you started. Can you just start me? All right. Madeline's going to start us. And you don't have to say very much. But what did your graph do from 100 to 0? So this is like Yeah, we're just keeping the story going. Go ahead.
It went down to 180.
It went down to 180, and where did it get to 180 in terms of the time frame?
Closer to
Like to here-ish?
like well,
Like here? Okay.
and then it went
Friends,
to,
shh.
and then went up to 300 in the middle.
In the middle, kind of at like 25,000 years ago. Okay.
And then it went down
To
to 220.
220 at about 1950-ish present time. Something kind of like that. What do you think? Or does yours match this? Pretty close? Because that's what science tells us, right? Up and down and up and down and up and down. Hayden, does yours match this too? Or no?
Not that big of a- like,
Tell me more.
like mine doesn't go down to 180, it goes down to like 220 as the lowest.
Oh, it just goes down to here-ish? And then how high up does it go?
Like 275.
Okay, so you kind of, it just went like, it was just a littler oscillation. Okay, so I'm gonna go ahead and throw that one in there. So it's kind of like to here and then like to there. And where did it end?
Like 260.
Okay, so kind of this gray one here. Okay, cool. Question?
I think that, like, at the end, the line is supposed to be going up since we're in global warming right now.
Yeah. So now, and this is where we're going. Spoiler alert. Spoiler alert. Things are not what they used to be. Okay? The reason I do this, and the reason I want you to see this, is because the oscillation should happen. You know what I mean when I say oscillation? It goes up and down and up and down and up and down. We talked about that at the very beginning of the year with waves a long time ago. But it goes up and down and up and down, and that's what should happen. That's natural. That's life is good. Life is normal. This is what we would expect. But, yeah. That's what it actually is. This is the actual data, friends. That should surprise you. That should make you open your eyes a little wider and say, oh, right? Draw this picture. 300 parts per million carbon dioxide in the atmosphere is the highest historical CO2 level. But look where we're at now. I can almost not reach the point, right? Like, it's so high. And it's only getting what? Higher. It's only going up. This oscillation stuff that we've been seeing for thousands and hundreds of thousands of years, that normal oscillation is no more. Okay? It's important. I want you to draw this picture, and then in the space somewhere on your brown sheet, I would like you to write 2 to 3 sentences right now about what you saw in the last 10 minutes of our conversation. Okay? So I want you to think about it. I want you to write down what you just put together in your brain. Okay? So I'm going to move you through this very quickly, and we'll talk about it more tomorrow. Okay? So listen carefully, please. I'm going to go straight down to the experimental design. In this experiment, if you're doing the whole experiment, you're going to take 3 test tubes, each containing a different gas. One's got air, one's got water vapor, one's got carbon dioxide. You put them close to a lamp, 10 centimeters away, which is not very far, about this far away from the lamp. And then you're going to measure the temperature every minute. Okay? You're going to heat it up for 10 minutes. Then you'll turn the lamp off and move the test tube away. And then take the temperature still once a minute for every minute for 10 minutes. Okay? That's the game. That's the goal. I don't want to say anything more because we've got to get cruising right now. So we're going to count off by 5s. All right? So we're going to count off by 5s, and then I'll tell you where to go. As soon as you get there, the first thing to do is to take the temperature of, or read the thermometer and find the temperature.